But it's raining outside, and I don't want you guys to get wet, so I don't know if you guys will melt or float or, but I don't want to find out. So I don't want to get wet either. So have you guys, all of you guys been associated with any type of meteorology type observation instruments at all? I mean, I'm guessing you guys have a 4-inch rain gauge, right?
Okay.
So,
I'm a co-op, so I've got an 8-inch.
so yeah. Okay, well, tell me your guys' names so I can kind of get an idea.
Alan Henricks, Decatur, Northwest
Oh,
side
okay.
of Decatur.
Oh, yeah. Linda Simmons, East Peoria.
Tim George, Maya Molina, Groveland.
Dale Groupie from Galesburg.
Lyndon Balding from Olney.
Kim Craig from Congerville.
Dan Craig from Congerville.
Harold Simmons, East Peoria.
Ron Mennel from Work.
Shay Cohen Payne.
I remember you, Shane. In fact, you tweeted before you came into the office.
Oh, yeah.
So,
Aaron Atwood from Jacksonville.
I'm surprised we have quite a few people from the southeast. I mean, thank you for making the trip up here. I know it was a pretty long drive for you guys.
144 miles.
Wow. How long did it take you though?
We started at 6 and got here about, what, 10 till 9,
Wow.
non-stop.
Well, thank you for making the trip up here. We appreciate it. And so I'm basically, well, my name is Eric Laufenberg. You guys have probably gotten emails from me. So I'm an intern here at the office. I graduated from the University of Oklahoma back in 2003, way, way, way long ago it seems. Probably closer to when they were born. I feel old. Anyway, but I mean, and I was an intern at the Radar Operations Center, which is basically, it's part of the National Weather Service that takes care of the radars. It basically does the new technology for like the radar upgrades, the software upgrades, the hardware upgrades that we've seen. And so I got to, experience some of that, which is really kind of cool, especially with the whole dual pole thing, because back when I was in college, they were still envisioning that. And so it's nice to see 10 years later, it actually come to fruition, so. And now you guys have probably heard about the new sales update, which allows a low-level scan. It basically does the lowest 3 or 4 tilts, and then it goes, back down to the ½ degree, and then it, goes back up toward left off, and then back up. And that's really going to help us a lot, especially with the, QLCS tornadoes that, like the brief spin-ups and things like that. That we usually have, issues with, especially in the fall and things like that. So it's definitely a welcome addition to the NextRev radar. Let me log in here. So has anyone mentioned anything about the weather balloons at all out there? Have you
They
guys
talked
heard
about
them?
them some,
Okay.
yeah.
Well, basically, so let's man this time. I must not be hooked up to the network. Oh, great.
Let's see if they come back.
Let's see if we can put it on this way. But they've been basically taking weather balloon observations for, I think it's close to over 70 years now, and I mean it's obviously changed quite a bit through time. But now we basically get a radio sound, and let me actually go grab one here while the computer starts up here.
Yep. have to take calculus, don't you?
I have to take a lot of math.
Yeah.
Yeah, it was,
That's what kind of prevented me from going much further.
well, here, go ahead and pass this around. This is basically the instrument package that we put on the bottom of it. You can turn it upside down, so it's right side up. But hopefully I'll be able to show you guys a little better picture of it here on the computer, but I'm not completely certain, although it looks like it may have stopped raining outside, so we may be able to go outside after all. But, so basically what you have is you have a balloon. It's a latex, balloon, and when we fill it up with hydrogen here, there are some offices that still use helium. The reason we use hydrogen here is because it's a much cheaper gas, and we can actually manufacture hydrogen as well, unlike helium, which has to be mined. So, and the U.S. supply, actually the world supply of helium is actually becoming, really almost rare. And obviously, there are a lot of, other uses for helium besides just us filling balloons and, people filling party balloons at birthday parties and stuff like that. So, and that takes obviously priority, not the party balloons, but over us. But, they use helium actually to cool the magnets on, for like X-ray machines and also, CAT scan machines and machines like that. So, and actually, I guess there's the U of I that's they're trying to recycle helium so that they're not using as much of a supply. They said that I've heard that they can reuse it about 7 times, which is a lot better than before when they would just use it once and then let it go. So, I mean, just like I don't know if you guys know a lot about helium, and I don't even want to talk a whole lot about it, but nonetheless, they usually find it a lot with natural gas and with oil. So, I mean, the same companies that deal with oil, deal a lot with the helium as well. So, let me pull something up here.
Now, they said the balloon bursts when it gets so high.
Yeah.
Does it separate from this box?
No. Well, basically you have the big balloon, and when we fill it up here, it's about 6 feet in diameter. About the time it bursts, it's about the size of a 2-car garage. So it's about 30 feet in diameter or so. And, it'll travel up about 20 miles up into the atmosphere. And depending on the wind, it can actually go, well over 150 miles downstream as well. And, although, sometimes in the middle of summer, we've actually had one here recently that, went all the way up and then it came back down, then it ended up just, on the north side of Lincoln. So, there are a few times where it does that. Obviously not very often. You have to have, pretty low winds all the way through the entire column. 20 miles up and then 20 miles back down. So, it's pretty rare, but, we have had several, SONs, which is what that is, the instrument package there is called. And, which have, even not at the, one like down in Lincoln High School, but right now we use dry cell batteries. We used to use wet cell batteries, and unfortunately they smelled a lot like rotten eggs, which it just happens to be the same smell you get from natural gas. So people, would mail them through the post office without taking the battery out. Well, the post office thought they had natural gas leak, so unfortunately that didn't go so well. So, but.
Are these little packs reusable if you get them back?
If you kind of see here at the top, there's actually a mailing bag, and it's it's actually prepaid, so you don't even have to spend anything to mail it back. All it asks is
you
just
reuse them.
it gets mailed to the reconditioning center in Kansas City. They may not be able to use every part of it, but different parts of it can be reused. So it definitely helps cut down the cost of these. Just looking at like the just the the expendables that we use on this, with the hydrogen or helium, you know, and the balloon itself is around $35. And, you know, this is, you know, probably close to 200, 250, maybe up to 300, somewhere around there. And, you know, of course, you know, the labor and stuff like that, I mean, but we do it twice a day, and here in Central Time Zone, well, they release these around the world at the same time. You know, we're at 0 and 12Z, or 0 and 12 UTC. And here, that right now, that happens to be 6 a.m. and 6 p.m. So I know I've been here at the office since 4 a.m. this morning, and I would normally leave at noon, but because I have visitors today, I get to stay later. So hey, it's actually nice. I mean, it's great to meet. No,
Gets to
it's great to
stay
meet you guys. I mean, it really is. And as I've told every other group that's been through here, we appreciate all your observations because, you know, that radar only sees so far down in the atmosphere. We don't really know what's going on until Shane sends us a photograph saying that I see a wall cloud. You know, or, you know, funnel cloud or something like that. So, I mean, we appreciate all that information because, I mean, especially when you get to the peripheries of our, you know, county warning area, you know, that radar beam is, you know, pretty high up and it's only seeing the middle part of the storm. So, you know, even at the lowest elevation scan. So, I mean, thank you for all your, you know, observations. Your rainfall reports are very helpful. I know, you know, at the most recent flooding event that we had in Champaign, I mean, that really is very beneficial, you know, and I got a question earlier, and I mean, it's great if you guys send in supplemental observations, like if you notice you get a, you know, decent amount of rain over a short period of time, you know, go ahead and send that in, but, you know, sending in a, you know, full day's observation is great. And also, if you want to do a storm total, like if, you know, you have a couple days of rain or something like that, or, you know, if you just happen to measure in the middle of a storm, you know, just, you know, go ahead and add that up if you want. Because either you guys add it up, or we're going to have to add it up. We don't really have any way right now of, you know, being able to do anything except for, you know, manually doing it ourselves. So, I mean, obviously we can get the computer to do it too, but it makes it a lot easier for us to make those co-op maps that you guys greatly appreciate, I know, and we like to make that as well, so.
We used to make a map with each rainfall at each one of our stations, and now you got a variable
Yeah,
color.
yeah, I think, I mean, unfortunately, we don't have our own little video here, so I'm going to use Flagstaff because they have some little cool graphics. But outside here, you know, just kind of talking about the instrumentation we have here. If you go outside, just, you know, right east of the trash, you know, container over here. Well, first of all, we have a generator, and we have the co-op building. And that building kind of stores all the supplies we have, and some of it's actually some swope stuff as well. And but there's an old, you know, kind of looks just like a little wooden box. It's a white wooden box. They call it a cotton region shelter. And basically what was in there is just maximum thermometers. And, you know, this is basically kind of the bare bones of where, you know, the National Weather Service and the Weather Bureau, where you guys some of you guys may even remember the Weather Bureau way back in the day, you know, back in the 70s and 60s and stuff like that. But, I mean, that goes back almost to Thomas Jefferson's time. And you know, some of the co-ops, you know, who report daily observations, they can get it's called the Thomas Jefferson Award, which is, you know, a very distinguished award that there are only 5 people around the entire country that actually get that award a year. So, I mean, it's a very distinguished award, and, I mean, it basically kind of gives, you know, accolades to, you know, one of our first presidents that, you know, really thought that measuring, you know, weather was, you know, a real, you know, important thing. You know, if it worked for him, we wouldn't have records dating back, you know, to, you know, near the founding of this country. So, which is kind of neat if you look at it. And when we have some of the, you know, the actual paper forms that people sent in, you know, from way back in the day, it's kind of neat to, you know, read a paper form that someone, you know, wrote back in, you know, the early 1900s or something like that, which is kind of neat. I don't know. I'm just weird, maybe. But nonetheless, we'll kind of show you these are kind of some of the steps that we do for the weather balloon. Do you want to pull up a little bit so you can see a little better. If I can.
Get down in front of you here. Oops.
Zoom around here so you can see it. There you go.
Hopefully you guys, most of you can see something. I'm very sorry about the tight quarters once again. But you guys are the only ones that get to see the computer demonstration of it, so I don't know if it's a. But nonetheless, there are people, you know, nicely dressed.
How did you get to that so that perhaps we could go home and look at it?
I might just send out, you know, some links to, you know, some couple of things for you guys to see.
Oh, that,
You know,
thank
so
you.
that way you guys can look at it at your own time.
Yeah, it looks
at
like you
home.
just Googled on it, so yeah, I'm.
Well, I looked at it this morning, so I promise it wasn't just looking like. But as you guys may have seen, you saw kind of a building that looks a lot like this when you drove up here. We didn't have the pretty little mountains, though. We don't have those around here. We have pretty little fields of corn and beans around here. So actually one of the guys here at the office came here from Flagstaff, so he's a lead forecaster here. But inside that dome, this is what it looks like. You can see an antenna like this, and this tracks this little instrument package. And so basically tracks, you know, there's a temperature sensor, relative humidity sensor, pressure sensor, and a GPS sensor inside of here. And that is being radioed back to us about every 2 seconds. So we're getting, you know, basically data about every 2 seconds during the entire flight. And we basically stop tracking it once it reaches up to, you know, when the balloon bursts, which, you know, typically is around, you know, close to 110,000 feet or around 20 miles up into the atmosphere. Like I said, it can go upwards of 150 or even more miles away. And during some of the storms, you know, especially the tropical systems, or, you know, especially in the wintertime when the polar jet is coming through us, and we can get wind speeds, you know, well over 200 miles per hour here, you know, around the area where jets fly. So, I mean, which is, you know, really nothing. You know, I mean, like I said, it can happen pretty often. This time of the year, typically the polar jet is far enough north, although this summer hasn't been typical, as anyone probably knows. But it's been here for quite a while. So that's what it looks inside the dome there. And the radar actually looks much the same. The NEXRAD radar, the taller dome out there, it kind of looks like a volleyball at the top there. It kind of looks a lot the same as well. And so basically we're filling up the balloon, and like I said, the balloon gets to about 6 feet in diameter. We're filling it up. And so, and we keep, you know, I don't know if you guys are familiar with, you know, gas cylinders. You probably have seen them at least carried around on trucks and stuff like that. But we get about 2 balloons each out of each one of those tanks. So, you know, there's a fair amount of gas in there. It's about 2,000 psi. If you guys ever seen Mythbusters, they show some pretty crazy things that these tanks can do if they get, you know, the head of the nozzle knocked off on them. It's not pretty, let me tell you that. It'll go through brick walls. So, obviously, it's kind of a safety issue, along with being an explosive gas. I mean, the Hindenburg, you know, may remind a few people.
Do they ever hit airplanes?
I just was gonna ask that question.
They are designed to actually go through an aircraft engine, but you know, I mean, pilots know that, like, we launch these, you know, twice a day, and so they are to be expecting them. And if you're around a tower at airport, you know, like cities, you know, I mean, all we have is just, you know, basically a county airport just right nearby us. Most National Weather Service offices are located near airports. You know, just kind of the way that they're located. But, you know, since we're not near a towered site, you know, where there are actually people in a tower all the time. Actually, there's no tower here in Lincoln, not even during the Balloon Festival. So basically, you know, they know that, you know, these balloons are going to be launched. And, I mean, they're so spread so far apart, but like I said, they're launched around the world around the same times as well. So, I mean, pilots generally know, you know, if they're going to be, you know, being launched. And I mean, the time that the balloons basically where an aircraft flies is only about 10 minutes. So, after that, it's well above where the airplanes fly. So a lot of the data that we get is, well above, where the pilots actually fly. So that, I mean, there's only really a minimum time of where it's, in a kind of a, vulnerable area for, planes flying. So
So how long does it take to go the 20 miles?
it takes about an hour and 45 minutes to about 2 hours. And then it takes about 45 minutes to come down. So I mean, it can end up pretty far away. I mean, the furthest I know that we've had one at least return to us was I think it was in northern Indiana. So I mean, they can go pretty far away. I mean, that's, about 120 miles away from here as a crow flies. And so, I mean, it can happen like that. So you can see here that she's attaching the parachute. So that the parachute's the orange thing over here. And so it goes balloon, parachute, then a long string, and then this instrument package at the very bottom. And we want this to be as far away as from the balloon to basically keep all the temperature, keep the balloon from affecting the temperature, and then also the humidity as well. But we do have issues sometimes. I mean, you guys know that, clouds contain moisture, right? Well, sometimes they contain ice. Super cool liquid droplets, which love to collect on our balloons. Love our balloons. And when that happens with the balloon becomes heavy. And so, unfortunately, it doesn't like to go up after that anymore. And it comes back to the ground well before we want it to. So, unfortunately, these are just the obstacles that we have to deal with. And, sometimes you can, kind of affect that or change the effect of that by adding more gas to it. But, I mean, we typically don't want to get about more than around 2,000 grams of lift. It's about as much as our balloons will take. Although, my previous job to this, I worked at the Department of Defense as an Army civilian in Utah. We had some missions out there where we had to help NASA because they had these, basically spacecraft that are coming back to Earth after they were out collecting solar dust and, different things like that. That they wanted to get basically to the periphery of the atmosphere as much as we could. And you have to get a really big balloon there. We use 600 gram balloons now, but we had to use about a 2,000 gram balloon. And when that thing is filled, it's close to around 15 feet in diameter. So it's a real big balloon. But that allows it to stretch, wider when it gets up to the top of the atmosphere. So it, it can kind of be exciting. I mean, you never know where you're going to get to go with, being a meteorologist. I mean, I know this sounds goofy, but I mean, one of the things I got to do at my previous job is we got to put instruments around the Pentagon. And, after that was done, we actually had instruments on top of the Pentagon. We had little tripods and stuff like that. And we had some around the parade grounds, which is where the president lands in Marine One when he visits the Pentagon. So, there was one night I went outside the Chiefs of Staff wing of the Pentagon, and there's a nice little stretch limousine, and I'm going out there because I'm changing out the storage module. And, they're looking at me, I'm looking at them, and I'm like, I don't think I'm the guy you're looking for. And I found out the next day, then Secretary Rumsfeld, uh-oh.
Oh.
It's all fun and games till somebody gets hurt. It's okay. No, you're fine. I'm just kidding. But I found out that Secretary Rumsfeld made it a surprise trip to Iraq. This is back in 2004, so 2005. So it was back during the last Iraqi war. But nonetheless, and I was also there one day when the president visited the Pentagon. And I mean, you see snipers, on top of the roof, and it's a real big deal. I mean, even around D.C. for the president to visit any other building around there. I mean we, obviously, if he comes to, like, if you were to come to Central Illinois, it would obviously be a big deal. But even if he travels around the D.C. area, I mean, you can definitely tell the president's moving around.
I was in Springfield a few years ago when he came to Springfield, and they pretty well shut the hotel down.
Oh yeah.
If you left, they said don't come back until a
Yeah.
certain time.
Oh yeah.
Or you could stay there, but
Yeah, when I was in the Department of Defense, I lived in the Salt Lake City area, and George W. Bush came to visit, and I mean it's really kind of interesting. And I mean I've talked to other people that have been that have been in the Navy, and I guess it really kind of depends on the president on how much security detail they have. So just kind of interesting in a way. I mean, you would think it'd be the same with Secret Service, but
it kind of paralyzes the whole area.
oh, absolutely, absolutely. I know when they had that G6 summit up in Chicago, I mean they had to shut down Lakeshore Drive, and I mean there was a whole bunch of things that they had to shut down up there. I mean it was a real big mess. But I mean we actually the Chicago Weather Service office got really involved with that. When we get really involved with if something like that's really public, they ask for special help from us because we're a government agency helping on another government agency. So we kind of work hand in hand. But I mean, obviously with your observations, it really kind of helps our job a lot easier. Kind of knowing how the storm system is moving through the area. So I mean, I can't stress how important you guys are. I really can't. I mean, it's great to have you guys. I mean, just thank you so much. And I'm sorry if I keep on mentioning that, but I really, really am truly grateful for all of what you guys do. So thank you very much. So she's attaching, you can see the parachute here. And I don't know what she's done with the parachute, why it's going that high. And she's tying another string. This is the part we don't do anymore. We used to have, remember I told you about them other batteries that smelled like rotten eggs? Well, fortunately we don't have these anymore, so we don't have any bomb scares at post offices, which is a good thing. I always felt really bad when hearing about something like that. But, and this is the old Radioson that we used to use. We use this one now. It's made by the same manufacturer. They're actually manufactured down in Mexico, but it's a U.S. company. And so basically what he's doing right now is what we'd be doing in that room that you guys were just in. I don't know if you saw that little foam block kind of where you guys were, but there's a GPS transmitter in the ceiling there that basically induces a GPS signal. So that allows us to baseline it. So basically we're wanting to make sure that the instrument, has a baseline so that we know that the pressure data is good, the temperature data is good, the relative humidity is good, all that stuff is, really good. And so after that, then they'll attach the, you probably don't really show it a whole lot here, but you attach, after you get that done, then you attach this instrument to the, like I said, there's a balloon, parachute, then the long string, and then the Radioson at the bottom of it. And then basically we just let it go. I mean, I'll just go ahead and play it here. And you can see that, with winds like that, it can make it tricky sometimes.
That is a long string.
A typical weather balloon flight can last in excess of 2 hours, and the Radioson can ascend to altitudes above 100,000 feet and drift more than 180 miles from the release point. During the flight, the Radioson is exposed to temperatures as close to 130 degrees below zero.
Don't worry about the audio here. In fact, we just turn it off, so that's not interrupting us here. But remember, like I said, that at the that it gets so high in the atmosphere, and I don't know if you guys have any idea of how what the temperature might be up there. It's around minus 50, Fahrenheit or Celsius. Yeah, minus 40. The Fahrenheit and Celsius scale are the same. So, was the Jeopardy question one day, and I was really happy. I knew it. None of the three contestants knew it. I was like, woohoo! I finally knew when they didn't, which doesn't happen very often. But so it made me happy. But nonetheless, but it's so cold up there. In fact, there are people in Alaska. I mean, these are things that people in Alaska talk about, because if you've ever been up to Alaska before, these people don't see people up there very often. So when they see new meat, they're like, I'm gonna get you, because they want to talk to you. But I mean, for whatever reason, these people up there are weird. They really like cold temperatures. They love it up there. I mean, that's what they live for. I mean, they're all about plugging in their cars in the middle of winter, with the engine heaters and stuff. But anyway, this electronic tech was telling me that, that you take a warm cup of coffee, and this is only colder than minus 40 Fahrenheit. Which to me is just, I've seen minus 23 Fahrenheit, and that's cold enough. But he says you take that warm cup of coffee, you throw it in the air, and it'll sublimate, which basically means it'll go from a liquid all the way into a gas without going into a solid before it'll reach the ground. Now that sounds kind of cool, I guess. I mean, if it's going to be that cold, maybe that might be something cool to see, but I don't think I want to see it.
Do it once, and they're done that. Yeah.
But nonetheless, let me actually show you. Oh, yeah, I was going to tell you. Okay, so temperatures, when things get that cold, what happens to them? Anyone? What happens when things get really cold?
Brittle.
Right, exactly. So basically the balloon becomes kind of brittle. So instead of, bursting like a normal balloon would, here at the surface, it shatters. Which is something that, to be honest, I never really thought about. But we had, there's a guy that lives over in Mansfield, which is about halfway between here and Clinton, just east of here. And he was, you remember last year when they had where, was it Venus crossing the sun? Remember that? He was, actually looking for Venus that day, because later that night he was going to have some kids from, Parkland Community College come over there and actually see that. So he was kind of looking at it. Well, he knew that Jupiter should have been, a part of a sphere, not like completely spherical, but part of a sphere. But he, put his telescope up there, and he's like, why am I seeing the sphere up there? What he was seeing was our weather balloon. So it just happened to be where Jupiter was supposed to be. He's actually since, seen another one of our weather balloons, but he kind of saw something, and he kind of saw something, he thought it was red dangling below it. Then he could see something kind of sparkly below it, which was the radiosonde. And, to me that's kind of cool. I mean, obviously for someone just randomly seeing this, him having no idea what it was at the time, no earthly idea. It was just one of them government conspiracy things to him. All that government, you never know what they're going to do. But he was tracking it. Then all of a sudden, he saw it turn into shreds. And then he's like, what was that? Yeah. Well, see, he didn't know. I mean, he wasn't sure. So, so these are kind of some of the fun things that we actually even deal with here.
There's a really good video of that I've seen.
Yeah, there's an initial video here.
So now Jupiter is not a planet.
It's gone.
It's a balloon.
Or the balloon burst. Okay.
And these people thought they were going to be cool and put a little bobblehead on their weather balloon that they sent up here. But this is a time-lapse video, so you guys can go ahead and watch it. And if you guys are interested, like I said, I can send out links to a whole bunch of different stuff that might explain some of this stuff a little bit more for all the different groups. But basically what they have a camera pointed up toward the balloon. And when they start showing the balloon again, kind of pay attention to the size of the balloon. So it only takes up, about that much. But you can see it just gradually starting to get bigger and bigger and bigger, right? And they pause it right before it becomes, right near where it's going to burst. So you can see where before it was, pretty small. Now it's really big. And you can see where it's, getting really big now.
Okay.
And if you're curious what this there is that, but as you can see there, it just completely shatters. And so then their parachute, which is kind of entangled inside, but I mean, you can just see it, and here's their little bobblehead doll. And it's just, you know, kind of funny, but, you know, you could put your, you know, least favorite whatever on there and just see them go, hey, yeah, no. But, and you can see that, you know, and like I said, this is a time-lapse video, but it's really kind of neat. I mean, because I'd never really thought about what happened. I obviously knew it was cold up there, but I never really thought about what happened to the balloon. And then I went searching for these videos on the, you know, on the internet, which there are actually several of them on there. This is just kind of my favorite one. But the Adler Planetarium in Chicago, they actually send these balloons up once in a while as well. And they use helium right now, but as I was talking about before, helium is becoming expensive. And so, you know, that they're, you know, wanting to, you know, still send these up because they're learning a lot of different things. And I mean, they have to launch their balloons from Kankakee because they can't launch them, you know, near the Chicago area just because of all the airplanes. So, so they have to, you know, drive down to Kankakee, and you know, they obviously have to kind of know the wind directions because there are these things up there called Great Lakes. You don't really want your instrument package to come down the middle of the Great Lake, you know, one of the Great Lakes up there. So they kind of have to, you know, watch, you know, so it doesn't come down on Lake Michigan. So, but I mean, they're actually, this is where, you know, so someone obviously had too much time on their hands. You can actually put in your payload and your ascension rate, and it'll give you an idea of where your payload's going to come down if you know your burst height. So
There's a website for that.
yeah, right, yeah. So there are all those fun things, but outside we have a rain gauge. We have a recording rain gauge. It records precipitation every 15 minutes. So that way, you guys don't have to be going out there every 15 minutes measuring it every 15 minutes, measuring another 15 minutes. I mean, it'd be a little tedious, and probably wouldn't get a very good accurate rainfall. But so we have those scattered across the county warning area, and those are used by NCDC, you know, basically to verify precipitation across the entire U.S. And those used to be, yeah, I know sounds funny, but even just 3 years ago, they were using punch tapes. But now they've all been converted over to digital format. So, so all of the data that NCDC gets now is all in digital form for them. They no longer accept paper forms, which is kind of sad in a way. Like I said, I mean, it's kind of neat to go back and look at some of these older forms that some people have actually hand wrote and stuff like that. I mean, it's kind of neat to go back and, I mean, you're looking at history too. I mean, especially, you know, some of these people, our co-ops, have, you know, we actually had a lady over there in Hoopeston that her and her husband did it for 60 years. That's a long time. It's a long time of dedication. And most of the time they recorded highs, lows of precipitation and snowfall in the middle of winter. I mean, 365 days a year, you know, it's obviously a big dedication. And with mobile families now, it's harder and harder to find people that are going to stay in a certain location for as long as they will, you know, as they have in the past.
Next year I'll be 50 years and we're getting a rain gauge or weather moisture.
Oh, wow.
50 years of records.
Well, congratulations. I mean, I salute you, sir. That's, I mean, it obviously, I mean, it really warms my heart to, you know, to be able to give words like that out, because it's obviously a lifetime of dedication. And I mean, a lot of these people, you know, a lot of them are school teachers, and I mean, there's in Morrisonville, just south of, kind of southeast. Well, yeah, you were there for that one.
Yeah, we got married on 9/11 before it became popular in 1960, and we haven't moved.
Wow.
And I started collecting in '65.
Wow, that's amazing.
Of course, I'm a farmer, moisture is important to farm.
Yeah.
I've got electronic for 6 years,
Hmm.
just on the website or through my weather station.
But I mean, whether you're slope or co-op, your information is invaluable to us. And I mean, all of that data, you know, gets stored in some way. And I mean, people 100 years from now can go and look at it and, you know, be able to tell how much things have changed here. And I mean, it's really kind of neat. I mean, to be able to think that you're part of history. I mean, you know, especially for you co-ops. I mean, you're at the official site for that locality. And even a lot of our slopes and our Kokoraz observers now, you know, they're, you know, for, you know, determining whether or not, you know, localities get, you know, federal funding, you know, if they had a natural disaster there. You know, they use a lot of that data now. So, I mean, so whether or not your community gets some federal aid, you know, for a natural disaster, it could be just from data you provide. So, I mean, that's how important your data really is. I mean, don't take it lightly, because, I mean, it really can mean something to someone out there, you know, to be able to get back up on their feet. So, any questions you guys have, maybe? I know I've talked a whole bunch here, and you guys are still awake, I think, most of you. Someone has to have a question. Come on, Shane. Don't.
Is it still raining? Can we go look at something
We might be
outside?
able to go outside.
We haven't been guided through the gift shop. They go on all these tours, they end up in the gift shop.
That's all right.
Surely we should be spared today.
I'll make it secret. We don't have a gift shop here. Sorry. But if you guys want to come down this way here, I'll show you some of the instrumentation I was talking about. And as you can see by the white stuff on the ground here, birds like to leave presents from time to time. So I'm sorry about that. Hopefully they didn't hit your car. And also something kind of fascinating about here, for whatever reason, we have birds that are very efficient here. They can build a nest on a tire. Yes, a tire. I don't know why birds build nests on tires here, but they do. They can bird a full nest in 8 hours in a shift.
They're expendable too.
Not too smart.
But nonetheless, it's kind of funny. So are any of you a ham radio operator? So if you guys send in any reports, it'll come through this radio tower right here. And so you probably noticed the ham station back there, behind you guys in the main weather room. And I talked about the 15-minute recording rain gauge. That's that white gauge right out there. And the tower behind that is, that's the wind. That gives us the wind speed for the upper air, for basically the surface condition for the fluid. And if right behind this building, right about this little contraption right behind you guys, that's the dumpster. But behind that is a generator. That actually powers our entire building. And the radar is actually powered by its own generator down there. So even if we lose power, which is very helpful for obviously during any type of bad weather. But you guys see the little claw thing on the top? Now last group, no one had a grandpa that did the claw. Anybody here have a grandpa that does the claw? The claw? No, not here either. You guys are a tough crowd. But basically what that is, that's I'm goofy, sorry. That basically is measuring the X and Y components of the wind. So that's using sound to determine wind speed direction. So that's basically a non-mechanical, wind detector. Yep. And I was talking about, when I was at the Pentagon, that I went outside to change the storage modules. We actually had two of those, one on top of each other, and that can measure turbulence. And if you guys are curious what we were doing there, we were sending a tracer gas, sulfur hexafluoride, if you're curious. It's a tracer gas that acts like a chemical or biological agent. So what we were basically doing is, if someone were to release chemical or biological agent, toward the Pentagon, what would be the safest route to evacuate all those people? 'Cause, I mean, there are about 100,000 people that work in that building. I mean, it's the world's largest office building, so it's quite an amazing building if you guys ever get the chance to visit the Pentagon. But so we were, basically, kind of doing that. And I don't know what the answer was, so you don't have to kill me. I don't have to kill you guys, which is more important. But okay, you remember that little antenna that I showed you that was on top of the top of the dome? Well, that's like the one of the shorter dome here. The taller dome, which I'm sure everyone wants to go to the top of. Right? Everyone wants to jog up 100 feet up to the top of it? No?
What about your soccer ball?
Soccer ball, volleyball? Yeah.
Volleyball?
Yeah, we call it pretty much the same thing, but it's a lot bigger than it appears. It's about 33 feet in diameter up there. But, and it's about 100 feet to the top of it, or just a little over 100 feet, I think.
Have you guys
If
replaced
you
it?
guys, I don't know if all of you like us on Facebook, but if you go back through, our posts on Facebook, you can actually see a tour of their radar from on there. So, which is kind of neat. I mean, because I've never been up there, so it's, really nothing special. I mean, because you can't go up there when the antenna's on, so you can't exactly, get fried by the microwaves. It's basically kind of the same technology that your microwave oven uses, really, just in a lot higher power. And it's more concentrated signal as well. But you guys have any questions or anything? You guys awake?
Now, where exactly do you turn loose the balloon?
It's anywhere around the building over here. And if you guys want to go over there, I can show you guys the inside of the building if you want. Those are the two questions you get asked all the time, believe me. So go ahead and go inside.
So we go up there with popcorn?
No, not that one.
Not that one?
This is the tall one.
Oh, okay.
So have you guys ever been in a gas chamber before?
Yes.
Well, you have now. Not really. But no, this is where we inflate the balloon. We basically, tie it off either on either end over here and go out either door. In fact, I'll just open one of the doors to just get some fresh air in here. And we have mechanical doors. We don't have door openers like you guys probably have at home with your garage door opener. Unfortunately, the door goes up pretty easily. But if you look over here, if you guys want to, this is where we store the hydrogen. So this is the secret stash. Okay. That's not so secret. Let me turn on the lights here. Turn on the lights here.
So each cylinder will fill 2 balloons?
It's about 2 balloons, yeah.
What's that cylinders are there? It's like the cylinders they haul around in those trucks that you
Yep,
see.
yep, that's exactly what they are. Now there's some remote things just like that. 'Cause the hydrogen generators are pretty dangerous to operate.